Guys, we've already done systems of equations, haven't we? We did them, right? What were the ways we knew how to do them? There were 4 ways. Elimination, substitution, matrix, and graphing, right? Do you remember that? Remember those 4 ways? Okay. Well, today I want to remind you the kinds of solutions that we can get. What types of solutions can we get to a system of equations? 1, how would we get one solution to a system of equations? If I had a line here and a line here, wouldn't that be one solution? Because the solution to a system of equations is what? Absolutely, it's the point of intersection, right? What's another possibility besides one solution? Okay, so all of them, right? If that was the first line and that was the second line, right? That's all real solutions, right? You remember that? Are those the only 2 possibilities? Then what's another possibility? No solution? What would no solution look like? So they are parallel, absolutely. Okay? That is no solution. Now, we already talked about the fact that we've already done systems of equations, right? So why would we do it again? Because it's fun? Okay, excellent. That's a good answer. I like that. There's not another way to solve it, but there is. Yeah, what have we been talking about recently? Parabolas, right? Quadratics. So what kind of possible solutions are there if we add in a quadratic to this mix? Oh, yes. 2, I heard somebody say 2. So something like that, where one solution is right there and one solution is right there. 2 solutions. 100% agree with that. Is that all? Hopefully you can tell it's not all because I already drew another graph, right? And I'll make you feel even better. What are other possibilities? One solution? Okay, what would one solution look like? So what would the other graph have to look like for it to? Oh, so a vertical line? I'm okay with that. Right? One solution. Is there another way? If that's my parabola, what about if I had a tangent line on my parabola? Wouldn't that also be one solution? Yeah, just by definition of a tangent line, right? Touches in one point. I know that's geometry, but it's also algebra. So it is only 2 solutions and 1 solution? Is that the only options we have? No solution? What would that look like? So there's the parabola, and then there's the line, like that. So no solution? Is that it? No solution, 1 solution, 2 solutions? So if you have a line and a parabola, can you have all real solutions? No. But what if you had 2 parabolas? Oh my goodness. Okay, so let's start drawing 2 parabolas. What would that look like? How many solutions could I get? 1. Okay, so maybe like this And what? What would the other one look like? Oh, so just touching at the vertex? Like that? One solution. Is there another possibility for one solution? So like this and like this. Isn't that also one solution? Right there? So on one solution, that's our only possibility with two parabolas? Oh, all real? So if one parabola was right here, and one parabola was right there, all real? Okay. Is that it? All real and then one? You could have two? Okay, what would that look like? So one opens up and one opens down like that. So two solutions. Okay. Is that it? Is that the only way two solutions could happen? So I could have one parabola like this, and then one much wider parabola, like that. So two solutions. So is that all we can have with two parabolas? One solution, two solutions, or all real solutions? No solution? What would that look like? Okay, so let me maybe one's up here, and then maybe one's down here. So no solution. Could there be three? Three solutions? So there's one parabola. So show me how I would put another parabola for there to be three solutions. Yeah, that's exactly right. You're thinking outside the box, right? This way. That's what he said. 1, 2, 3. Right? Because at no time did we say these have to be functional parabolas, did we? I just set you up that way with all the ones I drew, right? Trying to get you to think outside the box a little bit, and guess what? You did. So could there be 4? Four? 1, 2, 3, 4. Could there be 5? Not that I know of. Okay? Not that I know of. That doesn't mean it's not possible. It just means I don't know it. But there's a lot of stuff I don't know. Okay? I don't know how to fix a car. I don't know how to do brain surgery. I don't know how to do 5 points of intersection. Those are all about equal, right? No, I'm just kidding. You know that. You know that. Okay? Is there any other way to get 4 solutions? I didn't ever say it had to be a parabola, right? What if it's a circle? That's not a great circle, right? Don't judge my circles, rude. So what if there is a circle involved? 4 solutions is possible? Is 3 solutions possible? Here's my circle. Is 3 solutions possible? One, 2, 3. Is 2 solutions possible if there's a circle? Yeah, there's 2 ways, isn't there? Well, at least 2 ways. We've got this, right? Here and here. Or we've got this. Yeah, if it's a line, right? Circle and a line, wouldn't that be 2 solutions? If I have a circle and a line, can I have 3 solutions? Circle and a line, 3 solutions? No. No. Could I have a circle with a parabola or a line and have no solutions? What would that look like? So maybe the circle is right here, and maybe the line goes this way, or the parabola goes this way, and just doesn't touch it, right? Because if have we drawn all the possible solutions? No, that would take us a really long time, probably like forever, right? I just wanted to give you a good idea of what was possible, okay? What was possible with the things that we know so far, okay? Now that you know what's possible, now we need to talk about how we solve things like this. Are you ready for that? Yeah? Okay, exciting. What were the ways that you remember how to solve a system of equations? Elimination, substitution are the 2 that we're going to talk about today, okay? Graphing, we kind of already talked about it. We're not going to solve it by graphing, although you could, right? And matrix, can't use. No. Can't use it. Once you're past 2 lines, you can't use a matrix anymore, okay? Because calculator won't let you, exactly, okay? Y equals negative 3x squared minus 30x minus 71, and y equals negative 3x minus 17. Okay, that's my system. I would like us to solve this equation by substitution. If we're going to solve it by substitution, what does that mean again? Plug something in that I know into the other equation, right? Don't I know that y equals this? So can't I take this and plug it in right there? Wouldn't that be our substitution? So then it would become negative 3x minus 17 equals negative 3x squared minus 30x minus 71. Does that make sense? I took this and plugged it in right there. Well, doesn't this just look like an equation we solved last week? I mean, not last week, the week before. Yeah? What do I need to get it equal to? 0. So how am I going to do that? Add 17 to both sides, okay. Is that it? So add 3x to both sides. So 0 equals negative 3x squared minus 27x minus 54. Okay, so far? How do I go about solving this? Where do I go from here? What are my three options at this point? Completing the square, yes. Factoring. Quadratic formula, exactly. Okay. Which way do you want to try for this one? What? Quadratic formula? Okay. What's A? -3. What's B? -27. And what's C? -54. X equals -b plus or minus the square root b squared minus 4ac all over 2a. So I grab my friendly neighborhood calculator to help me out with this, right? Because I don't know what 27 squared is off the top of my head. Do you? I should know. Okay, I apologize for not knowing that. Okay. 27 squared is 729 minus 4 times -3 times -54, which is 648, all divided by -6. 729 minus 648 is 81. That's nice, isn't it? Don't we know the square root of 81? X equals 27 plus or minus 9 over 6. What's 27 plus 9? 36 divided by 6. What's 27 minus 9 divided by 6? 3. So what did we just figure out? Is this the point of intersection? No, it's not. Those are x's, right? So what did I just figure out? So how many points of intersection do we have? 2, right? We got 2 x values. So what I do to help myself remember is I go ahead and start writing my answers. How do I figure out the y value? Okay. Do you guys see my mistake? I see it. Can I fix it real quick? What is my nemesis, by the way? Negatives. Look what this is. Look what I wrote in the next step. That's a negative. That's a negative. So this is 36 divided by -6, which should be, and then 18 divided by -6, which should be, please forgive me. Okay, no, okay. I'll keep that in mind. I'm just teasing. -6 and -3. Those are my x coordinates of my 2 points of intersection, right? -6 and -3. How do I find the y? So right here. Could I go here? Yeah, absolutely. It's already y equals, right? Why would you choose this one then? It's easier, right? It's easier. So for when x equals -6, I have y equals -3 times -6 minus 17. So y equals 18 minus 17. Does anyone know what 18 minus 17 is? 17? Okay, awesome. Or 1. 1 is also fine. And then we have a -3, right? So y equals -3 times -3 minus 17. Or y equals 9 minus 17. which is negative 8. This is my solution right here. Right here. Okay? You good with that? Good? Okay, awesome. Since we did substitution first, what are we going to do this time? Now, I'm 100% agreement with you that substitution would be really easy on this problem, right? But I have to make sure you know how to do both ways, substitution and elimination. So I'm giving you this problem to do, and we're going to do it by elimination. Okay? Now, here's something you have to be careful of. Can you eliminate the x's in this problem? No, you cannot. This one's x squared and this is x, and the only way to make this a squared is by squaring both sides, but that would give me an x term on this side, because I would have to distribute, right? Which would then not be eliminating the x's, would it? It would be creating another x, and that's not good. So when you're doing an elimination, it's almost always going to be the y that you eliminate, okay? In this particular problem, if I'm going to eliminate the y, what has to be true about the variable we're trying to eliminate? Same but opposite, right? Same coefficient but opposite. So I have a y and a y. They're the same, but they're not opposite. So what do I need to do? Multiply by -1. Which one do you want to multiply by -1? Top or bottom? Bottom? Does it matter? It doesn't. He said bottom, so we're going to go with bottom. You ready with that? Is it okay if I go ahead and do this to multiply by -1? You all right with that? All right. So now what happens? Now I combine it exactly as it is, right? Because the y's that I need are lined up, aren't they? So what's y and -y? 0 equals? So I have a -2x squared and a 4x. Can I combine those? They just end up being -2x squared plus 4x, right? And then I have a -9 and a +1, -8. Can I go back to this question real quick? Guys, when you solve with the quadratic formula and you get answers like -6 and -3, what could we have done from right here? We could have factored it, right? Okay. And it might have been easier to see that we could factor it if someone would have recognized that all three of these numbers are divisible by -3. Did you say that? I just didn't hear you. Oh my gosh. You're going to be braver one of these days. You are. Yes, you are. Okay. If we would have divided this by -3, we would have been able to see that we could factor it. Okay. And in fact, the class before you, that's exactly what they did. Okay. They factored this. They got -6 and -3 just like we did, and they substituted again to get exactly the same points that we did. Okay, so I'm trying to make a point, first of all. Number one, let's make it easier on ourselves because we did a whole lot more work than they did. Okay, number two, even if you don't make it easier on yourself, can you still get the correct answer? Yes, you can. Okay, so now we're to this point in this problem. What do you think we should do from here? Will the quadratic formula always work? Yes, it will. Is it always the fastest? No. What do you want to do from this point? Divide by what? -2. Why are you choosing -2 instead of just 2? It makes our a positive. Good job. Okay, so I get x squared minus 2x plus 4. Now what? Factor it? Okay, go ahead. Uh-oh. Can we? Oh, do we give up and cry now? Oh, no. Okay, quadratic formula. A is what? 1. B is what? -2. C is what? 4. X equals -b plus or minus the square root b squared minus 4ac all over 2a. I am in choir. 2 plus or minus the square root of 4 minus 16 over 2. X equals 2 plus or minus the square root of -12 over 2. Do we know how to answer this question? 100% yes. But what does this tell us? It's going to have an imaginary answer. What does that tell us about this system? There is no solution. And I can stop right here and write no solution. I don't have to find the imaginary solutions because this is a tangible problem that it's asking. It's saying, where do they intersect? Well, if the answers are imaginary, do they intersect? No, we stop. Okay, I know you know how to find the answer to this. We've done several of these, quite a few in fact, right? But when we're trying to find the solution to a system of equations, we're trying to find tangible points of intersection, there's not any. You okay with that? Do you have any questions? I have one more example for you, if that's all right. X squared plus y squared equals 5. And negative x plus y equals -1. You know how sometimes the instructions say solve by substitution. So you have to solve by substitution. And sometimes the instructions say solve by elimination. So you have to solve by elimination. The instructions on this one is solve. That means you're going to decide how we're going to solve this. Okay? What do you notice first of all about the first equation? Oh, they're both squared. X and y are squared, right? Guys, when x is squared and y is squared and the coefficients are the same, this is a circle. It's a circle. Okay? So what is this one? That's a line. So I have a circle and a line. So think of all the possibilities that we talked about, and even think about possibilities that we didn't talk about. Because again, we didn't talk about them all, right? How many possible solutions are there with a circle and a line? 0, 1, and 2. We said there can't be 3, right? Can't have a line and a circle. You can't have 3 solutions from that. So it's either 0, 1, or 2, right? Just so we know like what to think about going into this, right? Okay, so how do you want to solve this? So if we're eliminating, remember we have to eliminate either all of the x's or all of the y's. Since I have a squared and a not squared, and a squared and a not squared, am I going to be able to eliminate either all of the x's or all of the y's? I'm not. Substitution is the best choice for this problem. Okay, so how would I solve this by substitution? So first I have to solve for one of the variables, right? And what he said was add x to both sides, so I will go ahead and do that. So that I get y equals x minus 1. Everybody okay with that? What do I do with the y equals x minus 1? I use the second equation to solve for y, so I need to take this and substitute it into the first equation, right? X squared plus what I know for y, which is x minus 1 squared equals 5. Now, I have a great fear at this point that you're going to not remember your algebra rules and mess up on the very next step. So let's do our best to not do that. Is that okay? X squared plus what? Guys, what does it mean for something to be squared? Multiply it by itself, which means I have x minus 1 times x minus 1. And what do I have to do? Distribute. X squared minus x plus 1. X squared minus 2x plus 1 is what x minus 1 squared equals. And if all you ever do is square the first term and square the last term, you will get it wrong every time. That's not a threat. It's not a promise either. It's just a statement. Okay? So just be real careful about that if you're having something squared. Okay? Now I just need to combine like terms, right? 2x squared minus 2x minus 1 equals 5. But it's a quadratic, so what do I want it to equal? Most likely 0. Can I fix this? See my nemesis again? 2x squared minus 2x minus 4 equals 0. What are we going to do this time that we forgot to do the first time? Common factor. Excellent. Okay. So if I factor, what am I factoring out this time? Negative 2? Oh, just positive 2 this time, right? Because that will keep my a term positive, won't it? So x squared minus x minus 2. Now we tried to factor last time, but it didn't work, right? Should we try this time? What two numbers multiply to be negative 2 and add to be negative 1? Multiply to be negative 2, add to be negative 1. 2 and 1, right? Negative 2 and 1, okay? So x minus 2 and x plus 1. Could I have used the quadratic formula to solve this? 100% yes, okay? Zero product property says, what do I do with each of these two factors now? Set them equal to 0. X equals, and so how many solutions do I have? 2 solutions, and how does the first one start? 2 comma something, and how does the second one start? Negative 1 comma something, yes? How do I find the something? Can I go right here? Y equals 2 minus 1. Ooh, that's a tough one. That was a terrifyingly long time. 2 minus 1. 1. But when y is negative 1, or excuse me, when x is negative 1, we have negative 1 minus 1. Excellent. That was much better that time. Much better. Okay? That's my solution. Okay? Any questions?